Hello again. So here we're going to use a comparison test to see if the series converges or diverges. The first thing that I would do is estimate this and say, well, this is basically like the 3 is not that important, the 5 is not that important, so it's basically like n over n squared. And then that would be 1 over n, and the series 1 over n diverges. So I'm thinking I'm going for diverge, and I'm going to compare with 1 over n. So I just get my original series, n plus 3 over the n plus 5 squared. And if you want to show that it diverges, then you need to show that it's actually bigger than or equal to a series that you know diverges. So basically, if this one is going to add up to infinity, and you know that this one is bigger than that or equal, then our original series is going to equal infinity or diverge also. So before I start doing a bunch of algebra, I want to take a look at the graph and see, does it look like it's true? Because if it's not true, I don't want to waste time doing algebra. I mean, algebra is fun and all, but okay, so here are the two functions. The original one is going to be red, and the 1 over x is going to be blue. And if you take a look at the graph, it's actually the blue one that is bigger. Our series is actually smaller, and I was trying to show it the other way around. So is there any way I could grab that blue function and force it down? So I actually can, and that would be basically you shrink it by a factor of 10, or in other words, if I change the 1 to a 0.1, that's going to make it 1/10 as tall. So if you look back at the graph, now you could see our red one is bigger than this new blue one, the 0.1 over x. So since it's 0.1 over x, that means that that series would actually add up to 0.1 times infinity, and that is still infinity. So even if I change this to a 0.1, that series will diverge, will add up to infinity. So now to do some algebra. So one thing that I would do is I would go ahead and rewrite the 0.1 as a fraction like that, and then we could multiply both sides by 10n, so there's the left side, and then multiply both sides by n plus 5 being squared, and then we get 10n squared plus 30n is bigger than or equal to, on the right side multiply this out, n squared plus 10n plus 25. And it looks like we have a quadratic. So I'll move everything to the left, 9n squared plus 20n, and then minus 25. And then when is that bigger than or equal to 0? So I would go ahead and usually do the quadratic formula to finish that one, but we still have a decent amount of work on this. So I think I'm just going to graph it and see, does that seem true? So it was 9x squared, and then plus a 20x, I'm trying to remember, and then it was a minus 25. I'm pretty sure that was it. And then when is that positive? So if you look at this parabola, then when is it positive? Sorry about the jumping around. So it's positive after you're past a 0.892. Then all of this part is positive. So this is true for n bigger than or equal a 0.89 something. Doesn't really matter that it was a decimal, because basically we're starting n at 1 or 0. So as long as this situation is true at some point, then it works. Okay, so that is one way to prove it using the comparison test. So this inequality here is true, at least for n bigger than or equal to 1. And then you might say, but this one started at 0. That's true, but when you plug in 0, that only gives you 3/25. And so if you add 3/25 to infinity, you still get infinity. And so since the one on the right diverges, that means the one on the left diverges. And so little happy face was correct. It diverges. And if you want to be done with this one and move on to the next, that's fine. But I would also like to show you, go back, and instead of using the comparison test, which took some algebra, took some guessing and checking, as well as graphing and quadratic formula and erasing. So instead, what if you use the limit comparison test? So use the limit comparison test using, forgot that was yellow, using the 1 over n. So in other words, take the limit as n goes to infinity. Here's the original, which is n plus 3 over n plus 5 is squared, and then divide by 1 over n. Well, if you divide by a fraction, that means multiply by the reciprocal. And then it's going to be the limit as n goes to infinity. On the top, there would be n squared plus 3n. On the bottom, there would be n squared plus 10n plus 25. And then you can just use L'Hopital's rule, and we'll be done in just 1 or 2 steps. So when you use L'Hopital's rule, it is then going to have 2n plus 3 on the top and 2n plus 10 on the bottom. And if you do L'Hopital's rule one more time, then it's going to be the derivative on the top is a 2, on the bottom is a 2, and then that is a 1. And so basically that's saying, in the long run, when you divide these two, so if you have a divided by b, and you get a 1, which is what we got, then that's essentially saying that a is equal to b. And if one of them adds up to infinity, then the other one has to add up to infinity. Therefore, it diverges. But the second method was definitely much faster.